everyone. In this video, we'll be discussing how whole numbers can be written as fractions and how to convert between mixed numbers and improper fractions. So any whole number can be written as an infinite number of fractions depending on how many equal-sized pieces the whole is split into. For example, if you partition the space between 0 and 1 into 8 pieces, then the whole number 1 can be represented as 8 because the number 1 is 1, 2, 3, 4, 5, 6, 7, 8 spaces away from 0, where the spaces are each 1/8 of the base unit between 0 and 1. And then by extending the partitioning process to the space between 1 and 2, the whole number 2 can be represented as 16 eighths because the number 2 is 9, 10, 11, 12, 13, 14, 15, 16 units of 1/8 away from 0. So 2 equals 16 eighths, but it's also true that the number 2 equals 6/3, as shown by this area model where the wholes are split up into 3 equal-sized pieces. And there's an infinite number of other fractions that are also equal to the number 2. Like you could say 2 equals 100 over 50, or 2 equals 14/7, and so on. And helping your students understand this concept is critical when you're working with fractions that are greater than 1. And all fractions that are greater than 1 can either be expressed as improper fractions or as mixed numbers. So when you're representing one whole as a fraction, the numerator and denominator will always be equal because the number of parts the whole is partitioned into, in this case 5, is the same number of parts that are shaded within one whole unit. So in this case, one whole would be equal to the fraction 5/5. And in an improper fraction, the numerator is larger than the denominator, which is why improper fractions are always greater than 1. So in this case, we have the improper fraction 13/5, and this represents two wholes because it takes 10/5 to make two wholes, and then there's these 3 extra fifths. And this amount can also be represented as a mixed number, which is basically a mixture of a whole number and a proper fraction. So the mixed number 2 and 3/5 is equivalent to the improper fraction 13/5. And technically, the mixed number 2 and 3/5 means 2 plus 3/5, but we don't usually write the plus sign. And when you're teaching students to convert improper fractions to mixed numbers, it's important to help them conceptualize the fact that they're making whole units. So, one way you might do this is to say, how many thirds does it take to make a whole? And when they say that it takes 3/3, you could say, okay, so if I have 10 thirds, then I definitely have enough to make a whole. Do I have enough to make two wholes? And if your students have a clear understanding of how to represent whole numbers as fractions, they'll say yes, because you have 6/3 to make two wholes. And they might even say you have enough to make three wholes since you have 9/3. And you can help illustrate this reasoning by drawing pictures as you restate their claims. So you could say something like, okay, so what you're saying is that it takes 3/3 to make one whole. And if I have 6/3, then I can make two wholes. And if I have 9/3, then I can make three wholes. Do I have enough to make four wholes? And when your students respond no, because that would require 12/3, you can ask them if 10/3 is bigger or the same as the number 3. And when they say that it's bigger because 9/3 makes three wholes and you still have 1/3 left, you can write the equation that 10/3 equals 3 and 1/3. Then you can extend their understanding by asking them if they could figure out how many wholes can be made from 14/5 without drawing a picture. And they might say that you can make two wholes because it takes 5/5 to make one whole and 5/5 to make another whole, and then you would have 4/5 left over. And you can help them write their mathematical thinking by decomposing the fraction as 14/5 equals 5/5, which is the first whole, plus another 5/5, which is the second whole, plus the 4/5 that they said was leftover. And then you can simplify this and say, okay, well, if I have this whole and this whole together, that's going to equal the whole number 2. And then I'll have the proper fraction 4/5 left over. And these types of number sentences can also help students develop an algebraic understanding of the equal sign because you're saying that this amount is the same as this amount, which is also the same as this amount. And if you ask your students to convert large improper fractions like 67/4 into a mixed number, they'll start to create their own strategies to solve the problem. So some might choose to add up 4/4 plus 4/4 plus 4/4, however many times it takes to get close to 67/4, similar to the process that we did in the green example. While others may decompose the fraction in a more efficient way by saying, well, 67/4 gives me enough to have 40/4, which would be 10 wholes, and I don't have enough to make another 40/4 because that would require 80/4, but I could do 20/4, which would be 5 wholes, and 40 plus 20 is 60. So then I would have 7 more fourths, which gives me enough to have 4/4 and then 3/4. And by decomposing the fraction in this way, this tells us that you have 10 wholes plus 5 wholes plus 1 whole plus 3/4. And so the improper fraction 67/4 would equal 16 and 3/4. And that would be a more efficient way of figuring out how many wholes are in 67/4. And then other students may use an even more advanced strategy where they'll take 67 and do long division and divide by 4. Because if you have your 67/4 and you split them up into groups of 4, the answer to that division problem will tell you how many wholes you have. So they'll say, okay, well, 4 goes into 6 one time. 1 times 4 is 4. Subtract that. I have a remainder of 2 tens. Bringing down the 1 tells me I have 27 ones. And when I divide that by 4, I get 6 ones. 6 times 4 is 24. When I subtract that, I have 3 as my remainder. And so what this tells me is that I have 16 groups of 4, and then I have 3 that are left over. And since the 67 was talking about fourths, if I have 16 groups of 4/4, that means that I have 16 wholes, and the 3 that was left over are the 3/4 that I didn't have enough of to make a whole number. And so that tells me that the fraction 67/4 equals the mixed number 16 and 3/4. And you can see that we get the same answer with whatever method you end up using. And regardless of which strategy your students use, it's helpful to give them time to develop their own strategies and discuss their results as a class because it builds conceptual understanding instead of just memorizing a procedure. Because ultimately, the long division method is probably the most efficient way to convert improper fractions to mixed numbers. But you really want to make sure that your students have a conceptual understanding of why it works. And these less efficient strategies will help them build that conceptual understanding. And then when you give them harder problems like 67/4, then they'll start to develop strategies that are more and more efficient. And then once your students know how to convert improper fractions to mixed numbers, you can challenge them to reverse the process and find improper fractions that are equivalent to mixed numbers. And again, your students will have many different strategies, but all of the strategies will use the conceptual fact that whole numbers can be represented as fractions. So some students might write equations like 1 and 3/4 equals 4/4 plus 3/4 and use that reasoning to show that 1 and 3/4 equals 7/4. While other students may draw pictures and count the pieces. So they might say, okay, well, if I have 1 whole and 3/4, well, that amount is going to be 7/4 because this whole can be split up into 4/4 And when I combine that with the 3/4, that gives me 7/4. And then other students may do it all mentally and just say that they know it takes 4/4 to make one, and those 4/4 combined with 3/4 make 7/4. And once your students have problems like this down, you can increase the difficulty of the challenge by choosing larger whole numbers. And this increased difficulty will help your students find more efficient strategies. Because if you ask your students to convert 23.5 into an improper fraction, they may start out by using a strategy like 2 halves plus 2 halves plus 2 halves, like 23 times, and then add 1/2 at the end to find out that 23 and 1/2 is 47 halves. However, this strategy is not very efficient, and it won't take your students very long until they realize that they could just say, well, 23, if I multiply that by 2, that gives me 46 halves, and that would be equal to 23 because each one of the wholes is 2 halves. And then they could add this to the 1/2 to get the same answer of 47 halves, and that method is way more efficient. So both of these strategies give the same result, but the multiplicative strategy is much more efficient. And you can lead your students to use the more efficient strategy by giving them harder problems that are really cumbersome to solve with less efficient strategies. So to summarize, the fact that whole numbers can be expressed as an infinite number of fractions is a foundational concept that has to be in place in order for students to understand how to convert between improper fractions and mixed numbers. And once they understand that principle, there's many different strategies they'll use to convert improper fractions to mixed numbers and vice versa. And as a side note, you can teach the conversion between improper fractions and mixed numbers in any order. In this video, I showed the process of converting improper fractions to mixed numbers and then reverse the process, but it doesn't really matter which one you teach first as long as the students conceptually understand why the processes work. So I hope this video was helpful, and I hope that you have a great day.